Now, a very interesting topic I want to discuss. Okay. And in this topic, many students have misconception that also I want to discuss. So let's see. Functions whose complement is same as their dual. Functions, those functions whose complement is same as their dual. Okay. So basically, now this is the special type of functions I want to discuss. This is a special type of Boolean function whose complement is same as their dual. Means basically, remember, I want to discuss functions. I want to discuss functions f for which I want to discuss function f for which f complement is same as f dual. Is this clear? I want to discuss those functions for which f complement is same as f dual. Is this clear? This type of functions I want to discuss. Now, before we discuss this, let me tell you some misconceptions that students have in this type of function. Okay, I want to discuss those functions whose complement is same as their dual. This type of functions I want to discuss for which f complement and f dual they are same. But in this type of functions, many students they have misconceptions. Let me tell you what are the misconceptions. Actually, the first misconception is that this type of functions they are called orthogonal. Okay, this is the misconception. See, first of all, this type of function. See, let me tell you the misconceptions. First of all, I want to discuss functions. Those functions for which f complement is same as f dual. Okay, this type of function I want to discuss. But before I discuss those, let me discuss the misconceptions that misconception students have for these functions. For these functions, what are the misconceptions students have? The first misconception is that students think that such functions are called orthogonal. This is a misconception. Okay, this is a misconception. Actually, there is no such term, orthogonal Boolean function. This type of term does not exist. This is not even a word, first of all. Okay, this orthogonal function, like this orthogonal Boolean function, this is not even a word, let me tell you. Okay, this is not even a word. Means in the standard resources, in any standard resource, this word you will never find. In any standard resource, in every standard book, every standard university, NPTEL, MIT, Stanford, any digital logic book, this is not even a word, first of all. Is this clear? This orthogonal function, or I can say orthogonal Boolean function, this is not even a standard word. This is not even a word. In any standard book, in any standard resource, okay, you will not find this type of function. So this is a misconception. Actually, from where these misconceptions are coming, let me just tell you a small point, that on the internet, if you search this orthogonal function, you will find two videos. Okay, two YouTubers are there who have created this. I can say this video they have created. They are calling this type of function where f complement equal to f dual. This type of function they are calling orthogonal. Is this clear? See, there is no problem here. So far, there is no problem because there is no standard name for these functions. So can I call them orthogonal? Tell me. There is no standard name for these functions. For these functions, there is no standard name. Okay, for these functions, remember, there is no standard name for these functions. Is this clear? There is no standard name for these functions. So if there is no standard name, can I call them orthogonal? Yeah, no problem. See, you can call them orthogonal, you can call them Go function, you can call them blah blah function. Okay, yes or no? So there is no standard name for these functions, first of all. But the point is, this word they are using, orthogonal function, this is not a standard word. First of all, this is the first point. The second point, it is fine. You use this word, that is fine. Okay, you are using this word, that is fine. Okay, both of them are using this word, that is fine. But the complete analysis is wrong. Okay, for this type of function where f complement is same as f dual and f complement they are same. Even if you use this name, does not matter. See, name does not matter. Okay, Shakespeare told, name does not matter. So name does not matter. But the analysis is also wrong. For this type of function, in these two videos, the entire video is wrong. The entire video, entire analysis, everything is wrong. is wrong. Okay, so why I'm telling you this, because you can see there are a lot of views. You can see 80k 18,000 views are there on this video. On this video also there are some views. So students are learning wrong concepts. Okay, so that is the reason I'm telling you this, that I just want to tell you what are the misconceptions. Both the videos, they are teaching the same wrong concept in the same wrong way. Okay, they both of them. So in these two videos you will see the same wrong concept in the same wrong way. Okay, I think this is the old video. I think this video, I think this is a copy of this video. Okay, so I think this was an old video, and this YouTuber created a copy of this video, and because this video was wrong, so this new video is also wrong. Okay, so this is what I'm saying. The entire video, the entire analysis, everything is wrong. Every fact is wrong. So let me tell you what are the misconceptions. The first misconception is for this type of function. The first misconception is that they are called orthogonal. Okay, this is the first misconception. Here, what is the misconception? First of all, this is not a word. Is this clear? This is not a word. I can say this is not a standard word. In any standard resource, this word is not there. Okay, a standard word. This is not a standard word, first of all. The second point, what is the second point? The second point, in these two videos, you will check that they are saying that this type of functions are neutral. Okay, these functions are neutral. They are saying these functions are neutral. These functions are neutral. Okay, these functions are neutral. This is also wrong. Let me tell you. This is also misconception. I am telling you misconception. This is also wrong. Also, then they are giving a formula. They are giving a formula that number of such functions. They are giving a formula without proof. They are giving a formula that number of such functions, that is, I think this type of formula they are giving. 2 power n minus 1, c 2 power n minus 2, something. This type of formula they are giving. This is also wrong. Okay. All these things are wrong. And these three same misconception you will find in both the videos. Okay, so you can just see what is happening. I think this new video, this is just a copy of this previous video, and this previous video was wrong. This video was wrong. So this new video is also wrong because this is just a copy of this video. Anyway, the point is, so many students, they are watching this type of videos and they are learning the wrong concept. So I just want to tell you that these things are wrong. Okay, so let me tell you, all of these things, these are wrong. Is this clear? So for this type of function, for these functions, remember, for these functions, all these three things are wrong. All these three things are wrong. Okay, all of them are wrong. And this is not a, I can say this is not a rocket science. You can easily see that these things are wrong. Now we are going to the analysis. Okay, let's do the analysis of this type of functions. Did you understand what is the function we are discussing? Please tell me. We are discussing functions. We are discussing functions. Okay, functions f for which f complement is same as f dual. This type of function we are discussing. Is this clear? We are discussing this type of function. So this type of function, they don't have any standard name. Yes or no? This type of function, they have no standard name for them. There is no standard name. So there is no standard name. You can call them anything. Okay, so let's call them, what should we call them? Please tell me. There is no standard name for such functions. For such functions, there is no standard name. So tell me, what should we call? Okay, let's call them Go function. For example, these people are calling orthogonal function. We can call them Go function. Okay, anyway, there is not a standard name. These are also, I can say, these names are also self-made. Okay, these are also self-made names, orthogonal. This is not a standard name. So this is the first thing, that there is no standard name for such functions. Let's call them Go functions. Okay, let's call them Go function. Go function means a function for which complement is same as dual. Is this clear? Is this clear? Please tell me. Now, let's see some examples. For example, let me give you a function. Okay, let me give you a function whose complement will be same as their dual. For example, 0, 0, 0, 0, 1, 1, 0, 1, 1. For example, consider this function. This is your exclusive OR. Yes or no? This function, this is your exclusive OR. Tell me what will be the dual and what will be the complement. Tell me what will be the complement of this function. Tell me what will be the complement of this function. Let me know. Complement of this function, that will be 1, 0, 0, 1, right? Yes or no? Now, what will be the dual of this function? Tell me. Dual means just reverse this. Just reverse this. Are they same or not? Are they same? Can you notice f is same as f complement is same as f dual? So who is go function? So f is go function, right? Yes or no? So f is go function. Is this clear? Please tell me. So f is go function because f complement f dual they are same. So remember f is go function. Is this clear? Please tell me. Is this understood? Is this understood what type of function we are discussing? We are discussing those functions for which complement and dual are same. This type of functions I want to discuss. Now I want to ask you a question. This type of function, should they be neutral? Such function f, should it be neutral? Such function f is neutral. Such function f is neutral. Is this true? Such function f is neutral. Is this true? The answer is no. The answer is no. For example, you can easily take example. Consider this function. Let me give you this function 0, 0, 0, 1, 1, 0, 1, 1. Consider this function, all 0. Tell me what will be the dual. Tell me what will be the dual and what will be the complement. Tell me. What will be the dual and what will be the complement? See, the complement will be this. Dual will also be this. So can you notice f complement is same as f dual? Is this? But f complement is same as f dual. But f is not neutral. Yes or no? F is not neutral. So this type of function, should they be neutral? Must they be neutral? Can I say they must be neutral? This type of function, you can see for this function f, this function f, for this function f, f complement f dual, they are same. For this function f, f complement f dual, they are same. But this function is not neutral. Okay? Is this clear? Please tell me. So you can see that for this function, remember for this function, you can notice f complement is same as f dual. Okay? But you can see this function is not neutral. This function f, you can easily see this function f is not neutral. This function is not neutral, but for this function f complement is same as f dual. So remember this statement, such functions must be neutral. Okay, such functions must be neutral. This statement is false because this function is not neutral. You can see. Okay, so very easy. You can see this type of functions must be neutral. That statement is false. Another function we can consider is this. Consider this function, that is a bar, b bar, c bar, or abc. Okay, so consider this function. You can see 1, then all 0, and then finally 1. Okay, so this function also you can consider a bar, b bar, c bar, or abc, this function. For this function, what will be the complement? You can apply the De Morgan law. If you apply the De Morgan law, then your complement that you will get, that will be a or b or c, and a bar or b bar or c bar. And if you find the f dual, that also you can easily find. If you want to find the f dual, then this or will become and, this and will become or. Okay, and you don't change the literals. Don't change the literals. So basically, if you find the dual, you can easily find the dual and you will get this dual. Of course, you can see both are same. Okay, you can see, because what you can do, you can write it a bar or b bar or c bar and a or b or c. So again, you can easily consider that this function, these two functions, if you notice, then from here you can consider that f complement is same as f dual. Okay, f complement and f dual, they are again same. So this is what I'm saying, that for this function what will happen? For this function f complement and f dual, they are same, but still you can notice this function f is not neutral. But you can see this function f, this is not neutral. This function is not neutral. Okay, and you can easily see that for this function f complement f dual, they will be same. F complement will be same as their dual. Okay, so if you find the f complement, then this will be f complement and the same will be f dual. This same will be f dual. So you can easily see for this function f, remember for this function f, you can see for this function f, f complement and f dual, they are same, but f is not neutral. Okay, so this is the point. So remember, functions whose complement is same as their dual, this type of functions must be neutral. This is false. Now let's find out for two variables how many such functions are there. Okay, so these functions for which this is happening, Let's call them go function. I am calling them go function because anyway there is no standard word. There is no standard word. So tell me, how many go functions are there over two variables? If you have two variables, how many go functions over two variables? Tell me. How many go functions over two variables? How many go functions over two variables? If you have two variables, a comma b, then how many go functions are there over two variables? Please tell me. Let me know. So you have two variables, a comma b. Let's create the go functions. Remember, for go functions, f complement should be same as f dual. F complement should be same as f dual. Okay, f complement should be same as f dual. Now notice something interesting. Notice something interesting. You tell me. Let's assume f is this: a0, a1, a2, a3. Let's prove it. Let's make a general proof. Tell me what will be f complement. Just tell me what will be f complement. F complement, that will be a0 complement, a1 complement, a2 complement, a3 complement. Tell me what will be f dual. Tell me what will be f dual. Tell me what will be f dual. F dual will be reverse of this. Yes or no? F dual will be reverse of this. F dual will be reverse of this. A2 complement, A1 complement, A0 complement. Yes or no? Now tell me when they will be same. Because go function means what? See, go functions means they must be same. Yes or no? Agree with me? Go function means they must be same. They must be same. They must be same. So what is happening here? So what is happening here? If they are same, so what is happening here? Can I say A0 should be, see, A0 complement is same as A3 complement. That means what? That means A0 is same as A3. Can I say A0 is same as A3? Yes or no? A0 is same as A3. And similarly, A1 complement is same as A2 complement. That means A1 is same as A2. Is this clear? Is this clear? Please tell me. Okay. So this is the property. This is the property they have. A3 is same as A0. A1 is same as A2. Okay. So remember, I can say this type of property these functions have. This type of property. A3 is same as A0. They are same. They are same. And A1 is same as A2. They are same. Is this clear? Please tell me. A3 same as A0. A1 same as A2. So how many go functions can you create over two variables? Go function, remember, go function, that will be this type of function. Please understand. Go function f. Go function f. This will be this type of function where A0 is same as A3. They are same. They must be same. And A1 is same as A2. They must be same. Yes or no? Is this clear? Please tell me. Is this clear? So now you can create such functions. For example, 0, 0, 0, 0. This will be correct. This is correct. For example, F2. F2, you can create like this. 0. If this is 0, this should be 0. If this is 1, this should be 1. F3. F3. If this is 1, this should be 1. If this is 0, this should be 0. F4. If this is 1, this should be 1. If this is 1, this is 1. So tell me, on two variables, how many? On two variables, how many? 4 go functions. Is this clear? 4 go functions you can create. Please tell me. Did you understand this? Please tell me. If you have two variables, then 4 go functions you can create. So if you have two variables, okay, number of go functions on two variables. Number of go functions on two variables. How many? You can check. You can check. Tell me, F1 complement F1 dual, are they same? F1 complement F1 dual, are they same? Yes. For this function, dual and complement are same. For this function, complement and dual are same. For this function, complement and dual are same. For this function, complement and dual are same. Yes or no? So for two variables, number of go functions, how many? Number of go functions for two variables, that will be total 4. So can I say this formula is wrong? So can I say this formula 2 power n minus 1, c 2 power n minus 2? Can I say this formula is wrong? See what this formula will give you. See what this formula will give you. Just put what this formula will give you. Let me know what this formula will give you. This formula will give you 2. So this formula is wrong. Yes, yes or no? Is this clear? So this formula is wrong. So this formula is wrong. Is this clear? Please tell me. Let me know. One by one, I am telling you. Okay. So this formula, if you think that this is the formula, this is wrong. This formula is wrong. Okay. Anyway, so you can see 4 Go functions are there. What about n variables? Or maybe what about 3 variables? Tell me. Number of Go functions over 3 variables. Tell me. Over 3 variables. Tell me. How many Go functions you can create over 3 variables? See, very simple. Very simple. You already know. These are the 3 variables A, B, C. Okay. These are the combinations 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. And then you have 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So these are the things you have. So tell me, let me know what will happen now. Okay. In a Go function, what will happen? See, if you have a Go function f, okay, if you have a Go function f, let's assume you have this Go function like A0, A1, A2, A3, A4, A5, A6, A7. Let's assume this is a Go function. Then what it means? It means f complement will be same as f dual. Agree? If this is a Go function, then f complement will be same as f dual. So I can say A0 complement will be same as what? A0 complement will be same as A7 complement. Yes or no? Is this clear? A1 complement that will be same as A6 complement. A2 complement that will be same as A5 complement. A3 complement will be same as A4 complement, and so on. Please tell me. Understood? A7 complement will be same as A0 complement. So this is the idea. Okay. So finally, this is the point that they will be same. See what is happening. If you have a Go function, then in the Go function, what will happen? See, in a Go function, basically what will happen? If you have a Go function, then basically what will happen? Can you notice? Can you notice from here? Can you notice A0 is same as A7? Agree? A0 is same as A7 because A0 complement is same as A7 complement. A0 complement equal to A7 complement. So A0 same as A7, A1 same as A6, A2 same as A5, A3 same as A5, A4. Is this clear? Please tell me. Let me know. A3 same as A4. Yes or no? So in a Go function, actually what happens? Remember, in a Go function, these things will be same. These will be same. Okay. These will be same. These will be same. These will be same. And these will be same. These type of functions, what we call them? This type of sequences, what we can call them? What we can call them? This type of sequences, can we call them palindrome? Can we call them palindrome? Yes or no? Can we call them palindrome? Please tell me. This is like palindrome. Yes or no? So this Go function, this is same as your palindrome function. This is same as your palindrome function. This is same as your palindrome function. Is this clear? So how many palindromes you can create? How many palindromes you can create? Tell me how many palindromes you can create. Let me know. So you can see, if I put 0 here, automatically, here I have 2 choices. But if I put 0 here, automatically 0 will come here. Okay. So you can see these type of functions are palindrome because this A0, that will be same as A7. This A1, this will be same as A6. This A2 will be same as A5. And this A4 will be same as A3. Okay. So you can see only here you have choices. Only here you have two choices. Two choices each. Here there is no choice. Yes or no? Please tell me yes or no. Here there is no choice. So how many functions you can create? Tell me. So number of Go functions over 3 variables. That is just number of palindromes. Yes or no? That is same as number of 8 length palindromes. 8 length palindrome bit strings. 8 length palindrome bit strings. Okay, number of 8 length palindrome bit strings. How many 8 length palindrome bit strings you can create? Correct? Yes or no? Bit strings. And that will be same as 2 power 4. Okay, that will be same as 2 power 4, 16. Okay, so tell me, if you have n variables, then what will happen? If you have n variables, a1, a2, and so on, an. If you have n variables, okay, 0, 1, 2, and so on, 2 power n minus 1, then in this, if this is a go function, then remember this value will be same as this value. They will be same. They will be same. This value will be same as this value. They will be same, and so on. Okay, there is a partition. So there is, for example, this type of part. Okay, so how many you can create? How many go functions are there? They will be same. They will be same. So how many go functions you can create? So finally, I can say number of go functions on n variables, that will be 2 power n minus 1. That is same as your number of palindrome bit strings. You can see this is same as number of 2 power n length palindrome bit strings. 2 power n length palindrome bit strings. Palindrome bit strings. Palindrome bit strings. Okay, is this clear? Palindrome bit strings. Please tell me, understood? Okay, number of how many 2 power n length palindrome bit strings are there? That also will be 2 power n minus 1. So this is your answer. I hope you understood. Okay, so go functions, another name, what I can say? Go functions, another name I can I call them palindrome function? Can I call them palindrome function? Okay, yes. So they are same as palindrome function. They are same as palindrome function. In these functions, one interesting thing is happening that, tell me, f of x. Okay, this is the decimal value. This will be same as what? This will be same as what? Tell me. F of x, this will be same as what? This will be same as 2 power n minus 1 minus x. Yes or no? This is the decimal value. This type of functions are go functions. Okay, these type of functions are palindrome function, you can say. So you can call them palindrome function, you can call them go function. There is another word you can say. In these functions, can you notice, just tell me, can I say a comma b comma c, that is same as a bar b bar c? Can I say? For example, f triple zero is same as f triple one. F010 is same as F101. Agree? Yes or no? Yes or no? So I can say these are the different names. This function a1, a2, an is equal to f of a1 complement, a2 complement, and so on, an complement. You can see f000 is same as f111, f010 is same as f101. For example, f110 will be same as f011. Sorry, f001. Okay, so like this. So this is what I'm saying, that all these things are same. Okay, all these things are same. Is this clear? All of them are same. And what is the formula? What is the formula? How many go functions? Number of go functions. What that will be? That will be 2 power n minus 1. This will be the number of go functions. Okay, so that's it. This is the complete analysis. I hope you understood. And this is your chapter. We have seen dual, self-dual. We have seen neutral function. We have seen this go function, means basically those functions for which f complement is same as f dual. So this type of functions also we have seen. We have done the complete analysis. How can you find from truth table? How can you find dual? Okay, please tell me, are you comfortable with dual now? See, we have done the complete post-mortem of dual. Okay, any question they ask you from dual, self-dual, or I can say those functions for which f complement is equal to f dual. Okay, these type of function, everything we have seen. Is there anyone here who had this misconception about these functions, go functions, those functions for which f complement is equal to f dual? Did you have those misconceptions that I told you? Did you have these misconceptions that this type of functions are neutral, the formula is 2 power n minus 1, C 2 power n minus 2. This type of misconceptions, did any one of you had? Please tell me. Did any one of you have? Okay, it is good if you are learning for the first time from Go classes, then it is good. Okay, because a lot of students, they have misconception, as I told you. Okay, so I hope those two YouTubers, I hope they will watch this Go classes video. Okay, I hope they will correct their concepts so that so many, I can say, students, they don't learn wrong concepts. Okay, and I hope after correcting their concepts, they give credit to Go classes. Okay, I hope they don't create a video, out of anger, that Go classes has, how can Go classes reveal our wrong concepts. Okay, so I hope they don't create a video out of anger, they take it positively. Okay, so, and they create, I can say, they correct their concepts. Okay, I hope they create, they do correction in their concept, and they give credit to Go classes, that yeah, okay, from Go classes we got to know that yeah, this concept was wrong, so we are correcting it. Okay, so I hope they take it positively. Let's hope. But for the students, I would like to say that, question, see, don't blindly follow anyone. Okay, don't blindly follow Go classes also. You can see we have given the proof of everything. Yes or no? Do you agree with me? I have given the proof of everything. Okay, from the basics we have seen what the dual, what the complement, how to find the dual, from the truth table how to find the dual. Okay, so we have seen the proof. We have seen the proof of every concept. Okay, in the Go classes we don't teach you any concept without proof. So for the students, I would like to say, all the students who are watching this video, okay, we will upload this video on the Go classes YouTube channel. After that, if some student is watching this video, I would like to say that, question everything. Okay, so don't blindly follow anyone. Okay, so if you think that there is a possibility of improvement, do that. Okay, the same thing works for teachers also, for faculties also. If some faculty, if some teacher is, see, mistakes can happen from everyone. Okay, mistakes can happen. Okay, that is the point. But once you get to know that yeah, you have done the mistake, then you should correct it. That is the point. Okay, see, mistakes can happen from everyone. Okay, from Go classes also mistakes can happen. Mistakes can happen from IIT ISC professor also. So mistakes can happen from anyone. Okay, that is fine. Mistakes are fine. But after getting to know that you have done the mistake, will you correct it? Okay, so I hope that they correct their mistake and they give credit to Go classes, that Go classes told them about their mistake. Okay, so anyway, so thank you everyone, and this session is over now. So please tell me, did you like this session? Let me know. So this video I will upload on the Go classes YouTube channel. Okay, and please like and comment on this session. Okay, because this is very important. Because what will happen, see, when I upload this video on the Go classes YouTube channel, some students who are blind followers of I can say those YouTubers, they will comment very negative things. Okay, so to those blind followers, I want to tell that please question everything. Don't blindly follow anyone. This is for your career. Okay, in the GATE exam, if some question comes from this concept, this question comes, let's assume in the GATE exam they are asking number of such functions which have complement is same as dual. So then you can see your marks will be gone. If you follow the wrong concept, your marks will be gone. So follow the right concept. We have told you everything with proof. Okay, every concept, every point, every formula, everything we have told you with proof. Okay, so okay, so thank you everyone. And once we upload this video on the Go classes YouTube channel, please comment and like. Okay, please comment. Okay, so thank you everyone. Okay, thank you.